memories, and all of you mute your phones so that there won't be disturbance. Now, in our day-to-day life, we see some objects. I'm teaching about upthrust today. Today, I'm teaching about upthrust. In our day-to-day life, we see some objects, they float in water, and some objects, they sink in water. For example, I just want to show you, this is the water, and then this is the water, and I place this object inside water like this. See, as soon as I place this object in the water, it went to the bottom of the water. We say it is sinking in water. That's why we say it is sinking in water. And I'm keeping this plastic lid inside water like this, and it is floating in water. You see, one object is sinking, other object is floating in water. Now I want to just push this object down like this. You see, it is, I'm pushing the object, it is coming up. Did you see that? See, I pushed it to the bottom, and again it is coming up. That means there is some force inside the liquid that is pushing the object up. Some force inside the liquid that is pushing the object up. This force, scientists call it upthrust. It is called upthrust. Now, what is upthrust? First of all, upthrust is a force. And whenever there is a force, it should be between two objects. So upthrust is a force that is between two forces, that is between liquid and the object. So we can define upthrust as the force that is given by the liquid to the object. Upthrust is a force that is given by the liquid to the object when the object is placed inside water, partially or completely. So this is the very easiest definition of upthrust. You can remember, first of all, what is upthrust? Upthrust is a force. Who will give upthrust to whom? Given by the liquid to the object. When the liquid will give the pressure to force to the object, whenever the object is kept inside a liquid, partially or completely. So can you tell the whole definition of upthrust? Upthrust is a force given by the liquid to the object when the object is kept in the liquid wholly or partially. This is the upthrust. Why scientists call it upthrust? Now you can call it up force also. Why don't you call it up force? Because it is upward force, you cannot call it up force. See, force means, see, it can act like this, force can act like this, or it can act like this, it can act like this. For force, there is no direction. But whenever I say thrust, it is a perpendicular force. It is a perpendicular force. So this is the correct word you have to use. You cannot say up force, you can say only up thrust. So in the first thing, we learned about the definition of upthrust. So upthrust is a force given by the liquid on the object when the object is wholly or partially immersed in a liquid. Now the second thing we are going to learn is the formula to calculate upthrust. Formula to calculate upthrust. Now upthrust is given by the formula. Upthrust is equal to V dg. Upthrust is given by the formula. U means upthrust. V. Some children write simply V means volume. Whose volume? What volume? They don't write. So I write V means volume of the body inside liquid. Suppose the body is like this. That means the total volume of the body is inside liquid. Suppose the body is like this. Only this part. This is the volume. So the volume of the body inside liquid, that is the V. And D means the density of the liquid. And G means acceleration due to gravity at the place. So upthrust depends on three things. Number one, V. V means volume of the body inside the liquid. D, density of the liquid, not the body. And G, acceleration due to gravity. Now if you say these three things, acceleration due to gravity is same at all places. That's why if you remove, you can write like this, is directly proportional to Vd. That is, upthrust is directly proportional to volume of the body inside the liquid. Number one, upthrust is directly proportional to the density of the liquid. So this relation is very, very important for us. The second relation is very, very important for us. What is that relation? Upthrust of a liquid is directly proportional to the density of the liquid. Now, based on this relation, we are going to see some examples. I want to show some examples. Number one, first example is given many times in SCE, SLC examinations. Number one is, question I will write, it is easier to swim in sea than in a river. Give reason. See that it is easier to swim in a sea than in a river. Give reason. This is the question that is coming sometimes in SE exam for 2 marks question. Now, whenever such question comes, you think about some things. Number one, what type of water is there in the ocean and what type of water is there in the river? See, if you think about a river, then a river contains fresh water. If you think about sea, it contains salt water. See, salt water has more density. We already know that upthrust is directly proportional to density. If density is more, then upthrust is also more. That is the relation we have to know. So we must answer the question like this. A river contains fresh water, but sea contains salt water. We know that the density of salt water is more than the density of seawater. Due to this, the upthrust experienced on us by the water is more in sea. So it is easier to float in seawater. So what is the total answer? First, you have to tell about what type of water is in the river, what type of water is in the sea. What will you say? A river contains fresh water and sea contains salt water. Next, you talk about the density. Whose density is more? We know that seawater contains salt, seawater is salt water, so its density is more than the fresh water. If the density is more, what happens? The upthrust is more. The water pushes us up, so it is easy to float in seawater and to swim easily. This is the question and the answer. The second thing is, a ship floats more. A similar question. A ship floats more in seawater than in river water. This is the second question. A ship floats more in seawater than in river water. Give reason. This is what the question is. It is just like the previous question. It is easier to swim in seawater than in river water. The same question. You have to think about the two types of water. River water has fresh water, its density is less, and sea water has salt and its density is more. If density is more, then that pushing force, upthrust is more, then it is easy to float. You see, I will draw sea like this. Say there is a ship like this. You can see, yeah. There is a ship. For example, this is inside the sea. Now it is up to here. See the depth here. The depth is up to here. But when it goes into the river, it goes like this. Did you see the depth inside? The ship is sinking more in river water and the ship is sinking less in sea water. This is the question asked. We know that river water contains, it is fresh water and sea water is salt water. And we know that the density of salt water is more. So upthrust is more. Upthrust is more. So it floats more. Here it floats less. This is the question. Now the third question is about the egg. For example, you see there is a glass and I am keeping some fresh water. This is the fresh water I am keeping. There's a fresh water and there is one egg in my hand. I just drop it inside. Can you see the egg here? It went to the bottom of the glass. It went. Now the same experiment I will do with salt water. Now this is salt and I am going to keep some salt and keep it in water. I kept in water and I am just mixing that salt water, and the same egg I am keeping in salt water. Did you see that? In salt water, the egg is floating, but in fresh water, the egg is sinking. How can you explain that in terms of density and upthrust? So, in the density of fresh water, is less, but when salt is added to water, the density increases. When the density increases, then the upthrust also increases. When the upthrust increases, it pushes up. Now let me show one picture. Now this picture, did you see this picture? And this is the beaker. This is the beaker and this is the egg. This egg is inside the beaker. This is fresh water. And somebody is here. That is the upthrust. This upthrust cannot push it up. It is very weak. The upthrust of fresh water is very weak. Now I added salt to that. Now the density increases. And the upthrust also increases. Now I will show like this. Now did you see that? So when I added salt, two things happened. Number one, density increased. Next, upthrust increased. See, this is upthrust. It is able to push the egg up. So that is why the egg floats. This is the water level. The egg floats in salt water, but it is sinking in fresh water. That is another question. That is also SCA question. So now the repeated question is, one repeated question is there, that is see, when you are pulling the bucket out of the well, then as long as the bucket is inside water, you can easily pull the bucket. But when the bucket comes out of the well, you feel the weight of the bucket. So for example, like this is the well. Suppose this is the well. This is the well, and you are putting a bucket inside. This is the bucket. This is the bucket, and the water is up to here inside. It is easier now. It is bucket is coming. It is easier. But when the bucket comes here out of that, then it is difficult. This is the question. So why it will be difficult when the bucket comes out of the water, and it is easy when the bucket is inside water? This is the question. So the answer is, when the bucket is inside water, there is upthrust of water. The upthrust is pushing the bucket up, and it will be easy for us. But when the bucket comes out of water, then there is no upthrust of water, but there is upthrust of air, but that is very, very less. Don't forget about upthrust of air. That is very negligible. That's why we feel the full weight of the bucket. So when the bucket is inside water, then there is upthrust of water on the bucket. But when the bucket comes out of water, there is no upthrust of water on the bucket, and the upthrust of air on the bucket is very less. That's why we feel it very difficult. This is one thing. Now I told about number one, the definition of upthrust, then the formula to calculate upthrust, then the factors affecting upthrust, that is density, then volume, then acceleration due to gravity, all these things I told. Then I gave 4 examples of upthrust in our daily life and the reason for the upthrust, reason why it happens. Now I come to the conditions of floating and sinking. This is also very important when you are preparing for SEE exam. There are 3 conditions for floating and sinking. Now, first condition is like this. First condition. Now there is a liquid, water is there. There is water. There is a vessel and there is water inside. And there is one object inside the water, like this. The object is floating on the water. Object is floating on water. When does an object float in water? Then the density of object is less than the density of water. This is the condition. When the density of object is less than the density of water, then the object floats on water, on a liquid. This is the first condition. Now the second condition is like this. This is the second condition. This is the liquid and this is the object, and the object is just on the surface of the liquid. It is not coming down. For example, ice. Ice floats like this. Ice floats like this. In what condition an object floats like this? The density of object is equal to the density of liquid. Almost equal to. Equal or almost equal. And this is the example of cork. A cork will float like this. Ice will float like this. Why ice floats in water? If a question comes, you have to say the density of ice is almost equal to the density of water. That's why it floats in this manner. Now the third thing I will tell is like this. Like a stone. Just like a stone. It is sinking. What is the condition in which a body will sink? When the density of the object is more than the density of the liquid. So, density of body is greater than the density of liquid, then it sinks. So there are three conditions you have to remember. Density of the object is more than the density of liquid, then it sinks. The density of object is equal to the density of liquid, then it floats. The density of object is less than the density of liquid, then floating will be like this. These are the three conditions we have to remember. So these conditions are finished. Now one more thing is remaining, that sometimes they may ask you this question. With this I will close. Prove that upthrust is equal to weight of liquid displaced. Prove that upthrust is equal to weight of liquid displaced. Sometimes this question will come. Now you know that upthrust, U means upthrust, is equal to, what is the formula for upthrust? V D G. We know that upthrust U is equal to V D G. But if you remember one formula, density is equal to mass by volume. You know that formula. Density is equal to mass by volume. So cross multiply this. Density into volume is equal to mass. Density into volume is equal to mass. See here, there is density into volume. So instead of density into volume, you can write mg. Here you have to write, since density into volume is equal to mass. This is the thing. Now, what is the formula for weight? W is equal to mg. This is the formula for weight. And mg is equal to weight. But what weight? Weight of the liquid displaced. So prove that upthrust is equal to weight of liquid displacement. You have to do that. Upthrust is equal to VdG, and Vd is m, and mg is weight. Like that you have to prove. Now according to Archimedes principle, what is upthrust? We will see that also before closing. How many of you remember the Archimedes principle? I don't know. In Archimedes principle, we are going to take the weight, three weights. Number one, this is one weight. This is called weight of body in air. This is the weight. First weight. Now there is the second weight we are going to take. This is called Eureka can. Eureka can. And Eureka can should be filled up to here. And you have to take the spring balance, the whole spring balance, and keep it here. Now this is the spring balance. Now this is the second weight we are going to find out. This is the weight of body in air. This is weight of body in liquid. This is the second weight. When the body goes inside the liquid, some of the liquid will come out, and that liquid is collected in a beaker like this. This is the beaker, and this weight also we have to find out by top pan balance. This is called top pan balance. So this is the third weight we are going to see, weight of displaced liquid. So in Archimedes principle, we are going to see three weights. Number one is weight of body in air. Number two is weight of body in liquid. Number three is weight of displaced liquid. So Archimedes principle says that weight of body in air is equal to weight of body in liquid plus weight of displaced liquid. This is Archimedes principle. Weight of body in air is equal to weight of body in liquid plus weight of displaced liquid. But this weight of displaced liquid is also called upthrust. That is why I told about this upthrust. So from this equation, you can find out that upthrust is equal to weight of body in air minus weight of body in liquid. So this formula you are going to use when problems like Archimedes principle come. So there are two formulas. Upthrust is equal to VdG, that is nothing connected to Archimedes principle. But when spring balance, Eureka can, everything is given, this formula you have to use. Upthrust is equal to weight of body in air minus weight of body in liquid. So what all we have discussed today? You see, some bodies float in liquid, some bodies they sink in liquid. The reason why they are floating in liquid is called upthrust. This is the first point I told, and I told the definition of upthrust. Upthrust is a force given by the liquid to the body in upward direction when the body is immersed partially or completely. And second thing I told is about the formula of upthrust. Upthrust depends upon three things. Number one, U is equal to VdG, that is the formula. Upthrust is equal to volume of the body immersed in the liquid, and D means not density of the object, but it is the density of the liquid, and G is acceleration due to gravity at the place. So when you are taking upthrust at a single place, then acceleration due to gravity is same. So two factors are very important. Number one is volume of the body inside the liquid and the density of the liquid. So when you add salt to fresh water, the density increases, then upthrust also increases. Therefore, like this, I am just remember this, how the egg floats when you add salt to that, and how it is easy to swim in the ocean than in a lake, then how the ship can carry more load in an ocean than in a river, and why it is easier to pull a bucket out of water when the bucket is inside water, and it is difficult when it is out of water. All these examples I told, and I told how to prove upthrust is equal to weight of liquid displaced. That is one proof I told, and how to calculate upthrust in Archimedes principle. So children, unmute your phones and say, any doubt is there in today's lesson? Dia?
Yes, sir.
Any doubt?
No, sir. It is clear.
Okay. Now the topic is refreshed, you know.
Yes, sir.
So if you want anything, you can email to me and I personally will interact with you. Okay, and you can clear the doubts to your friends as far as you have understood the topic. Okay, we'll meet again. Bye.
Bye bye, sir.
Bye.
Sir, when is the next class?
Next class, we can have on Tuesday. We can have on Tuesday, same time.
Okay, sir.
Okay. Bye all children.
Bye bye,
Bye.
sir.
Yes, sir.
Bye, sir.
Bye all children. Thank you for watching.
Thank you, sir.
Thank you,
Thank you.
sir.